Here we're being asked to sketch some angles in standard position, and I'm going to start off with 310 degrees. Oh, that's a nice and large line. I'm going to make that a little bit smaller. That's interesting. I have no idea why that just did that. I pressed the button. I'm going to undo stuff, and now go back to our regularly scheduled math problem. Okay, 310 degrees. I know that here we're starting at 0, and going positive is going counterclockwise. Going around the whole way would be 360, so I'm going to dial that a little bit back. And instead of going all the way, maybe go most of the way around. And here would be 310 degrees. For the second one, I'm doing 29 pi over 12. I know that a whole circle goes from 0 to 2 pi. And if I'm talking about twelfths, I'm just going to rewrite 2 pi as 24 pi over 12. I know that over here would be 1 pi. Pi over 2 would be up top. So that'd be another 6 pi over 12. So if we're going around the circle, we know we're going around more than one whole time, because that'd give me 24. 29 is 5 more twelfths, so not quite all the way up to my pi over 2. And that would be 29 pi over 12. And again, we're going counterclockwise because we're going positive. For the third one, we got negative 13 pi over 6. So first thing I notice is that this is going in this direction. So we're going to go from 0 to negative 2 pi going around. Negative 2 pi, if I want to write this as sixths, would be negative 12 pi over 6. So going around the circle, I'm going to end up at, there's one full circle. That's negative 12 pi. Negative 13 pi would be a little bit further. Here we're trying to find some coterminal angles. This is based on the idea that if I'm at any position in a circle, I can get back to that same place by going around another whole time. So I can go plus 360 degrees, otherwise known as plus 2 pi, or I could go minus 360 degrees, otherwise known as minus 2 pi, to get around. For all these problems, we're going to be asked to find both a positive and a negative coterminal angle. So looking at our first one, we start at negative 30 degrees. I'm going to add 360 to that. And when I do that, I get 330 degrees. To get a negative coterminal angle, I'm going to start at negative 30 and minus 360. When I do that, I get negative 390 degrees. Same thing for my second one, except now instead of 360, I'm going to add 2 pi to this. And when I do that, oh man, we've got twelfths. Let's rewrite this as 24 pi over 12, because when I divide this, I get 2. So now we end up with 23 plus 24 is 47 pi, and 12 stays the same, so we got 12. Same thing for going to the negative direction. We got 23 pi over 12, and we're going to minus 24 pi over 12. When we do that, we get negative 1 pi over 12. The last one, we're doing the same exact thing. I already did the 12th, so let's do 24 pi over 12. That gives me 13 pi over 12. And then if we subtract 2 pi, so negative 11 pi over 12, minus 24 pi over 12, move a little bit farther down, we end up getting negative 35 pi over 12. In all of these cases, we are either adding 360 or 2 pi, or subtracting 360 or 2 pi to get to our answer. Here we're trying to find reference angle for each of these things. I find it much easier to be able to do a reference angle if I draw my angles first. So I'm going to start off that way. So negative 31 pi over 12. We know that we're going in the clockwise direction, and going around once would be 24 pi over 12. And then I'm going to have 7 more pi until I get past where I'm going. Okay, so going around one full cycle would be negative 24 pi over 12. That leaves me with negative 7 pi. I'm going to call that negative 7 pi over 12. And hey, that's almost a reference angle, because we know that a reference angle is the positive angle formed with the x-axis. So if we're taking this as a rotation of negative 7 pi over 12, the reference angle itself would be the same thing, but positive 7 pi over 12. For negative 325, I'm going to start out by realizing this is almost a full rotation. It'd be negative 90, negative 180, negative 270, and at 325 I'm somewhere up here. To get to 360, I could think about, okay, well, I've got to do 360 minus 325, and when I do that, that gives me 35 degrees. So I've got 35 degrees left, and in fact, that, my friends, is my reference angle. And finally, we get 5 pi over 3. 5 pi over 3 is not quite 2 pi, so that's not quite 6 pi over 3. We're going to stop here in the fourth quadrant. And to get to 2 pi, I could do this as 2 pi minus 5 pi over 3, if I wanted to. And that would be 6 pi over 3 minus 5 pi over 3 is going to be 1 pi over 3.